Hey, welcome back. Steve Basic Architect here from the Build Show Network. So obviously I'm down in the hole. This is a new project that we're just starting. It's actually the Build Show Build Boston site, but we're going to talk about overall water management strategy here. So we did something here that, I like to do on my projects, but I haven't caught it in a video yet. So it's part of the fundamentals of basic water management, right? The best thing you can do with water is get rid of it as fast as you can. So you can imagine we're sitting in a hole here, obviously dirt on both sides, putting the foundation in. Well, one of the challenges is, should the groundwater rise, what happens to it, right? So in this particular house, we have an interior strategy, we have an exterior strategy, and then we have what I call a linked strategy. So it's a three-part system that we're going to do a quick review, and then we'll jump back to the studio and we'll break out Big Red, we'll break out the details, and we'll talk about it a little bit more in detail. But the start of it is we basically have our footing. Inside the footing, we bury a 4-inch PVC pipe. It's the full width of the footing, and the footing basically gets cast over the top of it. So yeah, it's a 4-inch PVC tunnel that basically links the inside to the outside. So you can see one here that it's got an adhered tape over there that the general contractor taped the ends so they wouldn't get filled with concrete in any way. You can see another one there, and then we have another one there. So we have 3 in this length of wall, and they're peppered throughout the foundation. But what I wanted to illustrate is, if I go in here now and I cut out that membrane, you'll see that there's the 4-inch PVC pipe there in place. And if I jump over and grab this stick, you'll notice that it goes right through the system. So what I'm basically doing there is, we have our strategy 1. It's inside the footing. We'll fill this up with 12 inches of stone. Inside that stone, we'll have a 4-inch piece of pipe that's wrapped in a filter fabric sock, if you will, and it gets buried around the perimeter of the footing. And that pipe will go to a sump pump and get ejected out somewhere, go to daylight, drain away from the house. But that's a backup system. My hope is the sump pump will never come on. And the reason for that is, on the outside, strategy 2, we'll have the same filter sock around a pipe. That pipe will then be embedded in a bed of stone. We'll look at that on the detail. And that pipe will then drain to daylight. So just over the hill here, the ground drops off pretty rapidly. We're going to dig a trench through here, maybe one off the front, and we'll have a couple areas where all of our groundwater management gets drained to daylight. Now, the reason for these laterals are that, should something happen in the exterior drain, like for example, say we get a clog between that lateral and this lateral somewhere in the exterior drain. Well, if I don't have the laterals, it means that system basically goes kaput, right? Because it can't allow water to flow. But if that locks up for some reason, water now has the ability to come in through this lateral, migrate down, and go out this lateral and basically bypass that blockage. So in this foundation, we're probably 450 linear feet of foundation. We probably have, I don't know, maybe 24 of these laterals. So basically what I've done is, I've taken our water management strategy 1 and our water management strategy 2 on the outside and linked them with our water management strategy 3, these laterals. So now if we go back to my original statement, where as this fills up with water, basically the outside of the footing and foundation wall and the inside of the footing, and I shouldn't even say foundation wall, because the hope is it should never get to the top of the footing, because the outside footing goes to daylight somewhere. And so we're always getting rid of water before it becomes a problem. And these laterals ensure that we never get any buildup of hydrostatic pressure in the stone pad here, because we always have that free-flowing ability to go out to our strategy 2 pipe and dump it out in daylight. Let's go back to the studio. I'll get Big Red. We'll get the foundation plan. We'll get some details, and we'll talk sub-slab water management strategy at the footing.
Hey, everybody. So, you might never have seen somebody put laterals in their footings. Well, now you have. So, we're talking water management laterals here in the studio. I got a detail. We'll pull it up, and we'll talk about what my intent and how I see it and why I do it. So, let's get Big Red in hand. Let's break out the detail, and let's have at it. All right. So, as you can see, I grabbed the detail right down there at our footing. So, get an understanding. Here's our footing, or our foundation wall, sorry. Coming into our footing. There's our rebar that goes on our footing. And then here is our footing. And you can see here is that 4-inch lateral. I have it dashed in, but it's basically a 4-inch PVC pipe that's placed in the bottom of the footing, and then we just cast around it. Now, I know some of you are probably thinking, well, why would you want water to communicate? Well, if that lateral isn't in there, and let's just say the water here rises to a level here, it's going to rise to that same level here, right? So the groundwater is a uniform load. It doesn't just push up on the outside and not on the inside. Groundwater, like regular water, is always seeking level. Now, yes, there's probably some instances where you have some ledge and there's, a little fissure of water that's running through that ledge that's not, leveling itself out. It's going from point A to point B, but that's not what we're talking about here. We're talking about groundwater that's saturating the gravel and sandy soil that is below grade there. Now, part of this water management strategy is also we have a drainage mat on the outside. So any moisture that's making its way down the wall, groundwater, which should be minimal because up here we're going to slope the ground away. We're going to have rain gutters taking the water away. But any water that does make it is going to get into that dimple mat, and it's going to find its way down here, and this is all fully waterproof. But basically, I'm trying to get that water into this bubble, and that bubble is stone, and that stone gets carried on all around the perimeter of the foundation. So it's wrapped in filter fabric so it doesn't get all clogged up, and any water that gets in there, I want it to be able to make its way into that pipe. This pipe here is going to take it to a sump pump, and the sump pump is going to eject it out, right? That's my whole water management strategy. And we have two of them in this house. One is going to the front, one is going to the back of the house. The one in the back of the house goes into a ground recharge system. Here in New England, a lot of our communities don't want the rainwater going into the road and then becoming part of the stormwater system where it has to go and get filtered and cleaned and such by our wastewater treatment plants. They want us to put it directly into the ground immediately. So the one in the back is going to go to a sump pump. That sump pump is going to pump it into a basically giant stone pit septic field in the backyard, and we're going to recharge the ground, but we're going to have it significantly displaced from the foundation and below the foundation level. This sump pump that's in the front of the house, we're going to have that at 1 inch higher than the sump pump in here. And the reason for that is if this pump fails, then that means the water will rise 1 inch higher beyond the float of that pump. It'll hit the front pump, and the front pump will eject it, and it'll eject it out to daylight in a location where the homeowner can see it. And when you see water coming out of that pipe, then you know that the primary pump has failed, because the only way the secondary pump gets called to action is with a failure of that one pump that is that inch lower. So by putting the laterals in here, any water that does migrate down here doesn't sit against my foundation. Remember, it's water management. And a lot of people have a hard time understanding this, even though it's right in the words. But, right, it's water management. It's not water stopping power. It's not water stop here. It's not water barrier. It's water management. So management means I provide a path. That's management, right? So any water that comes in here, these laterals allow this stone bed to communicate with that stone bed. Now this one doesn't have a pipe in it because I just need the water to get in there and find these laterals. And you saw out there, these are probably somewhere around a 10 to 14 foot on center. They get kind of sporadically placed, one or two per wall system, footing system, before we turn the corner. And the other beauty of these is that as water rises here, if this pipe had ever clogged, and I have seen it, I've been on jobs where we've excavated these, and I have pictures of these locked solid. But if we had a section for some reason that did get locked up, this water rising would also rise in the pipe here, and it would go downstream in the stone pit because it's all rising equally, and then it would return to a part of the pipe that was no longer clogged. So the lateral really kind of gives the ability to circumvent. If I have that straight pipe there, I can go through the footing, go downstream, and then connect to it if I had a clog in the pipe there. And that helps solve that. But basically what I'm really trying to do, and we have this stone bed that goes all the way across underneath our slab, is any hydrostatic pressure here, I equalize it with those laterals, and I ensure that I don't get, water pushing up here and this water, down there. That the minute it starts pushing, that lateral helps equalize it. And then when it gets to the height where it can go into the pipe here, it goes into the pipe here and it flows to our sump pump and gets ejected out. And that's how the system works. That's how it's designed to work. It's designed to work as a water management system, and that is the sole purpose of putting those laterals in. So anyways, there you have it. Water management laterals down at the footing. All right, everybody. That's what that detail looks like. And thank you, Big Red, for joining in. If you're looking for more, we have hundreds of videos, Build Show Network. Go check them out. A lot of them are mine, and I suggest at least watching mine 7 times. Yeah, that's what the science says to get the knowledge. So just going by what the science says. Other than that, if you're looking for more on this particular project, it is one of our Build Show Build Originals. So under the Originals tab, you can find Build Show Build Boston. I talked design, site design, the introduction. We did concrete. We got framing videos that'll be coming out soon. So it's all there. We're going to have 24 episodes. We're going from day 1 until day complete. So check that out. You can find me on Instagram also, Steve Basic Architect, putting up stuff daily, sharing it, discussing it, talking about it. And then lastly, you can find me on the Unbuilded Podcast. I team up with good friends Jake Brute and Peter Yost. And every 2 weeks we drop a new podcast that you can listen to. It's on all the audio channels. And if you want to watch the antics behind the scenes, go check it out on YouTube because we record them all too. So other than that, we're going to put Big Red to bed. We're going to call it a night. So anyways, until next time, long live our buildings.